So let us start 7.4, hypothesis testing for proportion. Remember that when we talked about population, we said that population has some parameters. The parameters for population include the mean or mu. You also had proportion, P. We also talked about standard deviation of population or sigma, and these are all parameters of the population. Well, we had hypothesis testing for the mean. Now we moved on to hypothesis testing for population proportion. So there is no mu. We are talking about P or proportion. As before, we have three different cases. We either have null hypothesis, which is saying that population proportion is greater than or equal to a constant, a number, which in this case either in decimal or percentage. Let us call it, for example, P sub 0 or any number that you like. This is just a constant. Its complement says the proportion is less than P sub 0. In this case, we have a left-tailed graph. The first category, we can either work with the rejection region or p-value. Second category says null hypothesis says the population proportion is less than or equals to a constant like P sub 0. Its alternative says the proportion is greater than a constant like P sub 0. In this case, we get a right-tailed graph. Right-tailed. Again, we can either work with the p-value or rejection region. And finally, if the null hypothesis says P is equal to P sub 0, population proportion is equal to a constant, its alternative says, hey, proportion is not equal to that constant. In this case, we get a two-tailed graph. Very well. So what are the steps? As usual, we have to follow some steps. Step 1, verify that the sampling distribution of p hat is the sample proportion, can be approximated by a normal distribution, or if we multiply n by p, sample size, by population proportion, it's greater than equals to 5. N times Q is also greater than or equals to 5. So again, P hat is sample proportion and P is population proportion. Second step, well, what is the null hypothesis? What is the alternative hypothesis? Next step, specify the level of significance or alpha. Now we need to find the critical value. If we have a left tilt or right tilt, we get one critical value. If we have a two tilt graph, we get two critical values by using Z table. Now we find the rejection region. Then we need to find the standardized test statistic, which is defined as a new formula. This is something new. We haven't seen it before. New formula. This formula says, hey, the standardized test statistic is defined as P hat minus P divided by square root of PQ divided by N. For simplicity, we can write Z equals to P hat minus P divided by square root of PQ times square root of N. These two formulas are the same. Now, if Z is inside the rejection region, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So let us take a look at one example to feel comfortable about what's going on here. Example on page 2. A researcher claims that, well, there is a keyword for us. Claims that less than, okay, another keyword, less than 40%. 40%. 40 out of 100 of US cell phone owners use their phone for most of their online browsing. Okay. So here's we have the claim. We have less than is equivalent to the symbol less than, smaller than. 40%. We have percent. So when you see percent, it means that the proportion is given to you. There is no mean, there is no standard deviation. You don't see any keyword like this in a proportion question. So a researcher claims that less than. So when we have less than, it means that our alternative hypothesis is given to us. Less than, alternative hypothesis. So we can quickly form our alternative hypothesis. It says proportion is less than 40%. So since we have the alternative hypothesis, we can quickly form our null hypothesis, which says, hey, proportion is greater than or equal to 40%. So we're done with our null hypothesis, alternative hypothesis. Now we have to move on and follow the rest of the steps. In a random sample of 100 adults 100, it means that n is given to us, 100. So here you have a sample of 100 adults. 31% of these people in this sample say that they use their phone for most of their online browsing. What is this 31%? This 31% is p hat, sample proportion. Very well. So it says at alpha equals to 1%, our level of significance is given. Is there enough evidence to support the claim? Support the claim. Well, what are the steps? Here we go. Verify that the sampling distribution is normal if NP is greater than equals to 5, NQ is greater than equals to 5. N times P, remember that your sample size is 100. 100 times P, it's not P hat, P, population proportion. 100 times 40% is 40, which is greater than equals to 5. How about NQ? Remember that Q is 1 minus P, 1 minus 40%, which gives us 60%. NQ, sample size, which is 100 times Q, 60%, is 60. Of course, 60 is greater than equals to 5. So the first step, we're done with the first step. We're happy about the first step. State the claim, null hypothesis, alternative hypothesis. We have already formed our null hypothesis, alternative hypothesis. Which one is the claim? Claim is less than 40%. So our claim is the alternative hypothesis. Well, okay. Specify the level of significance. Level of significance is given to us, 1%. Okay. Determine the critical values. Since it's a left-tailed graph, we only have one critical value. How do we find the critical value? 1%. So to find critical value, we use alpha equals to 1%, which is the area to the left. So what are we going to do? We're going to use normal CDF for 1%. By using the normal CDF for 1%, am I on the right track? Is it normal CDF? I'm waiting for you, class. Is it normal CDF? We are finding the critical value. And we're using the area. Is it normal CDF? No. Inverse norm. Excellent. We have to use inverse norm. Remember that When you have your area, you use inverse norm for 1%. Your critical value, let us use it. Let's go to our calculator. We have the area. Turn on the calculator. So second class, inverse norm. Area is 1%. Mu is 0. Standard deviation is 1. And we calculate that. We get negative 2 point. You can just round it to 2 decimal places or 3 decimal places. Both of them are fine. Negative 2.33. This is my critical value. Critical value divides the graph into 2 pieces. The green area, this is a left-hand graph, so we have a green area on the left-hand side. This is your rejection area. And non-rejection area. Now we have to move on to find standardized test statistic. Standardized test statistic. If this number is inside the green area, we reject the null hypothesis. Well, okay, let's calculate that. We know that our standardized test statistic is p hat minus p divided by square root of PQ times square root of N. Well, I already found my p hat, which is 31%. P hat is 31%. P hat or sample proportion is 31%. P or population proportion is 40%. So this is my numerator divided by square root of P 40%, Q 60% divided by 100. So if I flip that, I get square root of 100, which is 10. Well, standardized test statistics says, hey, I am negative 1.84. Is this inside the rejection region? Is this number inside the green area? Okay, let's take a look at our area. You know that this little area to the left is my rejection area. What is the dividing number? The dividing number is negative 2.33. Where is this negative 1.84? Is this inside the area or is this outside the area? This
outside.
is outside. Excellent. Thank you very much. This is negative 1.84. So it's not inside the rejection area. It's before negative 2. Negative 1.84 outside. Since Z is outside the green area, it means that we fail to reject the null hypothesis. Since Z equals to negative 1.84 is not in the green area, we fail to reject the null hypothesis. Unofficially, we can say that, hey, we are supporting our null hypothesis. We are supporting our null hypothesis. What's the meaning of that? There is not enough evidence at the 1% level of significance to support the claim that less than 40% of US cell phone owners use their phone for most of their online browsing. So to use our calculator, first, we need to go to stat. Then we go to test. So let's turn on the calculator, go to stat, go to tests. Now here, it's not a z-test. It's not a t-test. We don't have two samples, but it is one proportion z-test. So one proportion z-test. One proportion z-test. Let us select this one. Okay. One proportion z-test. So what is p sub 0? P sub 0 is actually 40%. So 0.40. What is our x? What is our n? So how do you identify your x? How do you identify your n? What are those values? We have all the information that we need. What do you think? So which one is x, which one is n? Here you have a sample of 100 adults, 31%. So what is x? 31, nice, and n is 100, excellent. So 31, 100, so which case is this? Your alternative hypothesis says, hey, it's less than. So we're going to select the middle one and calculate. Here we go. This is our z, negative 1.84. We also have our p-value. P-value is 3%. 3% is greater than 1%. So we fail to reject the null hypothesis. You can say that, hey, p-value is almost 3%. 3% is greater than alpha, which is 1%. So we fail to reject the null hypothesis.